All right, so now we are going to go on to asynchronous JavaScript. So this will be between me and Jay, and we'll go into more in depth about what these promises actually do and how to actually work with them. First, I'm going to go through some terminology, synchronous and asynchronous. Synchronous just means that in order to take my next step, I have to finish whatever I'm doing. So if you ever took like 6100A, 6111, whatever they call it now, or like 6009 or like 61, I actually don't know the new numbers anymore. Basically, in order to run this next line of code, you have to finish whatever you're currently on. So this is synchronous processing. Asynchronous processing, now we're going to get into, where you can start multiple types of work at once and wait for them all to run at the same time. So I'm going to give you a cool analogy or a more high-level analogy on how these promises actually work using the analogy of ordering a package. So let's say you're Abby and you really love cats, and there is some assortment of cats that you want to have. There is a catalog of cats. And as you can see, Abby really loves cats, and these cats are kind of just vibing. Unfortunately for these cats exist somewhere really, really far away, let's say at some big corporate online retailer. And in order for her to actually get the cats, she needs to ask for it or buy it. So she goes to this website, she presses buy, and kind of in a sense places an order or a post request. What she receives back from this retailer is a confirmation saying, I have your order. Now, there are three things that could happen. One, the package could be delivered. Everything was smoothly. She asked for a package. The package came back. She comes to her door. She opens the package, and all the cats that she requested landed. Something that could also happen is that the cats are on their way. Maybe the manufacturer is still making the cats. Maybe it's on its way in between on the road, or maybe it's almost there. Either way, when she checks the status of her order confirmation, instead of saying delivered, it's going to say it's in progress or it's ordered. The last thing that could happen is that something went wrong. Maybe on the way from the retailer to her, maybe the cats just fell out of the truck, unfortunately. So when she checks her order confirmation, what it says is, oh, something went wrong. The package may be lost. So this is a very analogous to promises, where after placing a delivery order or creating a promise, you're going to have one of three statuses. One, it could be fulfilled. The delivery could be successful and you're happy with all your cats. Second, it could be pending. You could be waiting for the promise to get back to you, and you're just looking at it and waiting for it to come. And the last thing is that the promise could be something called rejected, which means that something within you placing the order to the order going there, or processing the order coming back, something went wrong in one of the steps in between. So I'm going to review the .then. So let's say that we're going to try upon the first load of the web page, I want to place an order of cats. So here there is useSpecs with an empty dependency array, meaning this is the function that we're calling upon the very first order. And I'm going to make this post request, /API/order kitties, to order me some cats. So initially, this post request is going to be a promise object. So it can have three statuses. It could be pending, it could be fulfilled, it could be rejected. Right now, we just have no idea. But we use something called .then. .then, using .then, you're able to specify a function that says, if this promise is fulfilled, what exactly do I do with this information? So we can see in this callback function, the parameter is delivered cats. If the cats are actually delivered, what do I do with these cats? Well, I'm just going to give these cats a big hug. But what if the promise doesn't actually get fulfilled? Well, if the promise is rejected, we can actually use something called .catch that says, do something, do this, if something went wrong with my delivery. So here, my function is going to say, console log, oh no, with a pleading face, the cats fell off the truck. Very similarly, as you saw in workshop 3 and 5, that there is a GET request for all your stories. You're going to ask the server for all of the stories, and it could be either fulfilled, it could be pending, or it could be rejected. You don't actually know yet. But you specify a .then and a function to say, once I get the stories, if it is actually successful, what do I do with these stories? Well, in this case, what we do with the stories is we load these into our state using the setStories function. What is a better programming practice is not only specifying what it does when the promise is fulfilled, we also want to tell it what it does when something goes wrong. In this case, you can add a .catch. Maybe with an error message, something like, this is so sad. Any questions so far? All right. So I'm going to give you an example of why we want asynchronous code instead of synchronous code. So let's say that Abby is working very synchronously. And when she places an order, she has to watch that order until it goes back. When she places an order and waiting for it, she cannot do anything else. She has to wait and look outside the door and wait for the truck to pull up and give her the package. So when she sends an order, she's blocked from doing anything. So she has to wait for it to go back. And maybe she wants a lot of cats. So she places another order and she gets back. And maybe she wants to do something on the side. So she stops all the cat ordering that she does. And she does all her other chores. Maybe she cooks some food. Maybe she gets lecture feedback to the other lectures. Maybe she goes to the gym and gets some gains. And after she's done with all of her side work, then she places more orders and gets it back, and more orders and gets it back. Ultimately, she is really sad because she just wastes so much time just watching the order go and watching the order come back. What asynchronous processing does is, let's say at the start of the day, she just places all of her orders at once. And throughout the day, she does all of her tasks, like cooking food or disciplining the lectures or getting gains. All the while, the orders are being fulfilled one by one as she's doing her synchronous tasks. Now she feels super productive because as the orders are being fulfilled without her watching, she could do all of these things that she wanted to do. Just like promises, sorry, this thing is in the way. Just like promises, promises stop the cat lover from wasting time watching her orders go and coming back. Promises stop us from wasting time by allowing us to write other types of code. For example, I'm going to create another example. I'm going to say on the first refresh of my page, I'm going to place an order for some cats. So, and it's going to be really slow. This is important. So I'm going to asynchronously place a cat order. That says I'm going to place an order. And if the order is fulfilled, I'm going to take my cats and I'm going to let the world know that my cats were delivered. And then I'm going to do some synchronous things on the side. Maybe I'm going to go cook some food. Maybe I'm going to go lecture the other lectures. Maybe I'm going to go get some gains. What this actually runs in code is that all the synchronous things print first. And then it's going to say cats delivered, and then the type of cat, the fluffy cat, the red cat, the blue cat. This is because even though I place the order first, it is an asynchronous function. When I place the order first, it is happening. And as it is happening, as it is processing, I'm able to do all these other synchronous things until finally the dot then runs and it actually comes back. Are you with me so far? All right. Something cool about promises is that the dot then actually returns another promise. So it might be a little trippy, but this guarantees that we can do promises one after another sequentially. But what if we want to use multiple promises? Well, we have to be really careful. Let's say that I'm going to say A, let's say slow number is going to asynchronously ask for a number, and A is going to ask for 9, and B is going to ask for 10. If I try to do A plus B, I'm not going to get 9 plus 10 because A is not a number, it is a promise. B is also not a number, it is a promise. So we cannot just add these two together. Otherwise you get something like this. This is not 19. So something we have to do is a little bit jank. We have to say A dot then and wait for A to actually be fulfilled. And then when A is fulfilled, we will do B dot then and wait for B to be fulfilled. And then finally we can actually add these numbers together. So this is going to be a little messy, but let's say that we have many promises. We can't just do a really long chain of dot thens. So luckily, there are some things in JavaScript that are able to help us. First is promise.all. Promise.all returns a function that resolves to array of the input promises. So it's going to wait for all of these promises to be fulfilled at once, or eventually. There's also promise.wait, promise.raise, that waits for the very first promise to get back to me. Whether that accepts or rejects, it doesn't matter. I'm just waiting for the first one that comes. Promise.any is going to say, I just want any of these promises to work right. So let's say I send out 5 promises and the first 4 get back to me and they don't fulfill, but the last one does. That's okay, because I'm asking if any of them actually fulfill. Now I'm going to hand it off to Jay for a better notation using await.
Okay. I'll move back through. Okay, cool. So we're going to talk about async await now. And async await is a different notation for how we can wait for a single promise and use its value. But as we just saw, we can actually aggregate lots of promises into one promise. So we can use it with promises.all, promises.race, and promises.any as well. But first, let's talk about what an asynchronous function actually is. So first, we can talk about what a synchronous function is. And these arrows represent control flow. They're like what code is currently running. So in the first example on the left, we can see that we start running the orange function, and then the orange function calls the red function. So the red function is going to run, and then when it's done, we're going to return to where we started in the orange function just after we called the red function. Okay. However, in the asynchronous code, we are going to call the red function, and the red function, instead of having to be completed before we start running the orange function again, can actually give control back to the caller. And when it does that, the orange function can run again while we wait for something in the red function to finish. So the main nice part of this is that if there's something very slow in the red function that doesn't require we actually do anything actively, we can just wait on it to complete instead of having to wait for it to complete while stopping the orange function from running. Let's get into more detail on how this actually looks. So we can imagine that synchronous control flow, let's say that we had some functions sync get and sync set stories. They're like the get and set stories that we saw in previous examples, but they're completely synchronous. And the way to understand what's going on here is that these boxes are code. The arrows that are solid are control flow, and the dotted arrows are going to be like possible control flow, which we'll get into because it matters for async. With synchronous control flow and synchronous code, if we got some stories with sync get and then we called sync set stories, we couldn't run handle click until we actually finished both of those other functions or both of those other statements. And that means that we are going to take a really long time to actually handle this user's click. We'll talk more about why that's actually bad, but that's like one of the main motivations for async. We can run handle click at a time where the website will feel more responsive to the user if we use asynchronous control flow. So this diagram again is can be interpreted the same way, but we actually have a dashed or dotted line between handle click and stories and the other blocks. So what this means here is first we get our stories promise, and then maybe we run handle click. And then after handle click is done, we're going to return back to the stories promise. And then from there, we can continue by running set stories. But this is one possible way this is one possible way the program could run. There are a few other ways too. So another option is that we run the handle click very early on in the get instead of later, like in the previous slide here. So in this example, we're going to run handle click pretty early on, and then that's going to return control back to the get. And then from there, we can use the .then to set the stories. Or lastly, the handle click could be run when we are handling the sets, when we're running the set stories. And these are all possible ways that we could have run our program. But the point is that by allowing for these multiple different ways to execute, we actually let our code be faster because handle click isn't waiting on either of these two things to complete before it runs. It'll run whenever whenever either of the promises on top is actually is waiting and can't make progress because it's waiting on something else to happen. So altogether, you can contrast synchronous control flow to async control flow with this sort of non-determinism or possibility of running multiple different things. We don't know which of these green graphs will run. We just know that one of them will, or that some other permutation will. So now onto await syntax. So instead of using .then with slow number, we could use await, and await is going to just wait for the promise to resolve and use the value. It's almost the exact same as .then, and in fact, any use of .then can be turned into await, but it's convenient because we don't have to write as much code and we'll just get the value out of the promise. One thing to note is that if a promise is not fulfilled, if it rejects, then await is going to throw an exception. So you have to be aware of that when you're dealing with promises that can fail. This code, though, won't actually work in VS Code. The reason why is because it's not in an async block. So you can only use await when you have the async keyword in front of your function definition. So let's see how long it's going to take to print A and B. If A takes 3 seconds to await or to complete, and B takes 5, then how long will it be before this prints? 3, 5, or 8? 1 finger for 3, 2 for 5, and 3 for 8. Yeah, exactly. So because we await A before we start awaiting B, it's going to take 8 seconds. And if we instead, we could use something like promises.all to make it take less time, because then we'd be waiting on both of them simultaneously, but that's not what this code's actually doing. So only asynchronous functions can use await, but you might wonder how we can actually make an asynchronous function. It's pretty simple. The syntax is you put an async in front of the list of parameters. This function takes no arguments, so that is empty and just like a pair of parentheses. But if we had arguments, this would still work. And then we can use the await keyword. Keep in mind that, again, the way this code is written, like we'll first wait for A and then wait for B, which could take a while. You might want to use one of those one of the promise like functions like promises.all to make it take less time if you're worried about that. This is actually equivalent to this code where we use .then to first get the value for A and then get the value for B, and then we log the result. But the code using await is a lot shorter, and it's probably easier to understand because we're not having to think so much about all these callbacks being passed around. And this is especially noticeable when we have lots of things we're waiting on in sequence. So if we have like 4 promises that we're trying to wait to complete, and then we're going to use something that results from all of them, that is a lot more code if we use .then versus if we use await. In general, you can use async await to rewrite anything you do with promises. And over time, it's becoming more common than the normal than the traditional .then notation. We're still going to use the .then notation in workshops just because it's probably more familiar to you, but the async await syntax is well supported and you should use it if you find it comfortable. So now, we can use async await notation in useEffect, and these 2 blocks of code are the same. Again, like if we await the get, we're going to then just get the value into story objs. And story objs is actually going to be an array of story objects. It's not going to be a promise. So you can think of await also as kind of unwrapping a promise into whatever is contained in that promise once that promise is fulfilled. So we have to write this code this way because useEffects itself must take a synchronous function. We can't actually make useEffect using async callback as far as I'm aware. So because of that, we make this function named getStories, and then we call getStories. But because we can call an async function, because it's just like returning a promise, and that's fine inside of a synchronous function. But what we can't do is we can't await an asynchronous function inside of a synchronous function. That rule's kind of strange, but in short, if you're in a sync function, what you should do is you should write a separate like inner function that is asynchronous, and then you can just call that function directly. And if you're in an async function, you don't have to worry about it. You can just write the code direct. You can write the code without wrapping it. Any questions so far? Okay, if any further questions come up, feel free to use weblab.is/questions or the help queue or the Piazza. So why do we actually want to use async in general? And I don't mean just like async functions or like the async keywords. I mean like promises or asynchronous control flow. We touched on this a little bit when we went over like how control flow works in asynchronous programs, but we'll talk about it more here. So JavaScript has something called the event loop, and it handles everything that the user does as well as that your code is running, including things like button presses and like key inputs. So okay, so this is a lot of code. Let's walk through it. This is pseudocode for what the event loop is actually doing. And first, we can think of the event loop as basically this infinite loop that constantly checks if there's some event. And an event is like an input event. So it's like if someone presses a key or if someone clicks the mouse. And if there is an event, what we're going to do is we're going to run that event. So we're going to take that event off of our little queue, and then we are going to run the function that we said we were going to run when that event was like scheduled. We need that function because most of the time, well, anytime we actually care about an event, we are going to attach a function that we want to run when it happens. The reason why we do that is because if we didn't want to do anything when an event happened, there wouldn't really be a point in like noticing that the event happened, if that makes sense. Because if you're going to do nothing for an event anyways, why bother keeping track of it? And then after we're done handling the event, we're going to run some code. And to run some code, what we're going to do is we're going to take a random thing that's a random promise that's waiting to run, and we're just going to run that promise. And when we run that promise, that's what generates our non-determinism in the control flow. Like the reason why we don't know when something's going to run is because we don't know what promise is going to run next. We kind of just pick it arbitrarily. So to like actually work together, promises and events have to work together to make this event loop code run properly. So there's roughly some function that lets a promise wait. And when a promise says it wants to wait, it's going to add itself to the queue of waiting promises. And then it's going to give control back to the event loop. Why does it have to give control back to the event loop? If it didn't do that, then the event loop, like we would never get back to running this loop again. So we'd never, like after a promise said it wanted to wait, we'd just be stuck. But we instead go back to the event loop. And that means that eventually our promise will run again. And events also just have to like add themselves to that events queue as well. So to notify that an event has happened, we're going to add the event and the handler to the event queue. And they're like two separate queues for promises and events because they're different things and they kind of run in a different way. Also, I think in a real event, we would probably have the loop for the events as well, because we'd probably run all of the events that are waiting, not just one of them, but that's not super important. The big idea is like we run an event and we also run some waiting promise. And this gives us responsiveness because it means that if there's an event to run, we can actually handle it. Was that all clear, or should I go back to the slide and like go over something? Okay. If you have questions doc is again totally open. So why wouldn't we just use synchronous functions all the time with our event loop? Well, whenever we run a synchronous function, there's actually no way to return control to the code that can handle things like button presses or inputs. So whenever we run synchronous code, it's like we're having to stop the loop and do something that takes a very long time. If we had something like sync get, for example, then we'd be stuck waiting for that function to run for like the entire time that we're waiting for a request. And it can take like 250 like milliseconds or up to a second really for HTTP requests to run, which is a really long time for a user because if you press a button and then the website doesn't respond for a whole second, you'd be pretty annoyed if you had to press a lot of buttons. So instead, we can use asynchronous functions. And the arrows going off of this loop kind of represent that control leaves the loop when we have to run some kind of promise or when we handle some kind of input event. So the arrows leaving the loop are because the loop isn't running sometimes. And when the loop isn't running, or like the loop is not what is like currently being progressed through. Sometimes we're running actual code that we care about, like a promise or like an input event. And therefore, we have these branches off of the loop, and those represent running code that we act with like a button press or something happening. And we can respond to those button presses instead of being forced to wait for whatever we were previously doing, because whatever we were previously doing nicely told us that it could be paused here because it wasn't doing anything actively. It was just waiting for something else. So yeah, when we use synchronous code and synchronous functions exclusively, we're going to get a pretty unresponsive web app. But we have a very responsive web app with async functions because we get the ability to do other stuff while waiting for slow things to happen. It turns out that set state is also asynchronous under the hood. I touched on this earlier with the control flow example and set stories, but set state is specifically asynchronous because we want to be responsive when React is re-rendering our front end. So we talked about the React lifecycle like previously, and the React lifecycle goes has a rendering phase. That rendering phase can take a while. And if we ran the rendering phase, whenever whenever any story changed, or whenever any state changed, really, that would mean that we'd be pausing from responding for all user input whenever our UI changed. And that'd also be pretty convenient as a user, because it means that whenever you input something, you'd have to wait a while for the re-render to happen before you can input something again. So for that reason, well, why couldn't we just group all the changes together, like group a lot of changes together, so we only do one re-render for every 100 changes or once per second? That would still be pretty unresponsive in that every time a lot of changes happen, the website just kind of freezes and doesn't respond to your input. So for that reason, what we do instead is we make set state asynchronous. And when set state is asynchronous, we get that responsiveness because when we're doing a render, there's also some waiting. And while we're waiting for the render to actually complete, we get to respond to user inputs and button presses and that sort of thing. So the user doesn't actually have to notice that there's a re-render going on, because that's really what we want. We don't want the user to have to care about the re-render or have to notice that it's slowing them down. So now we're going to go through some examples of when async is a good idea to use. And for the most part, we already can use async for all of these things, and it's pretty much the default. So when we're communicating between different devices, for example, there are a lot of places where this communication can get very slow. So all of these operations where we're communicating between different machines or different servers or different computers can take basically an unbounded amount of time. We have no idea how long it will take for our GET request to reach the server, or for our database query to reach the database, or for the database to give the server back an answer, or for the server to send back the database's answer to the client. Since we have no clue how long any of these things will take, if we were to just wait for them to complete before we continued, and synchronously, then we'd be stuck waiting for a possibly very long time without being able to re-render the web page or to respond to any input from the user. So the website would be very unresponsive. Also, in general, there are a lot of background tasks that we can run without stopping the user from interacting. So something like fetching data. Periodically, Facebook has to reload the posts that you currently see, and that could take a while if there are a lot of new posts. So Facebook can fetch those pages asynchronously, or fetch those posts asynchronously. And with those posts, it can eventually publish them, and you'll see them on your screen with when it re-renders eventually. Or when we're downloading or uploading large files, we probably don't want to, when we're downloading or uploading something, have to just watch our screen and not be able to use the website at all. So we can use async to make downloads or uploads, something that doesn't block our responsiveness. Specifically, if we're playing music or videos on Spotify or YouTube, we probably care a lot about our site being responsive because we want to be able to pause while we're watching a video or listening to music. And if our website didn't have any sort of async way of doing that, we'd actually just be unable to press the pause button. It wouldn't do anything. So we need that happens because when you're playing something on YouTube, you're downloading the video. So if while downloading a video, you were stuck waiting for that to complete before you could do anything else, YouTube would be very unresponsive and pretty much unusable. And lastly, if you're running some slow computation on a server, well, then you also care about using async, because if you had to wait for the whole computation to run, let's say it took several seconds, your website is again blocked from interacting with the user, which we also don't want. And there are a lot more use cases like this, where you're waiting on something else to happen, and you don't want the website, and you want the website to stay responsive. So in that case, in general, you want to be using async. So to recap, we can use the await keyword to wait for promises to resolve. And you can think of it as sort of like unwrapping a promise into the inner value. Although keep in mind that it throws an exception when like the promise rejects. You can use the async keyword to define asynchronous functions. And you can only use the await keyword inside of async functions. And anything you can do with a promise and promises.then can be rewritten with async await syntax. So you can use whatever you prefer. We use async when we don't know how long something is going to take. For example, for React rendering, talking between the client and the server, or the server and the database. And for, in general, background tasks where we need to like preserve something being responsive, but we also care about this other operation happening so that we don't have to wait for it in the future. Is this time accurate? Yeah. Okay, yeah. Be back at 1. Don't eat here.